All right, guys. Hey, welcome back to another lesson. Okay, today we're going to talk about congruent triangles. This is a step into side, 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 side angle, side, and all this other stuff that we're going to get into the future. So this lesson kind of sets that up for it. So let's go ahead and talk about this. Okay. So just a quick recap. Congruent means that two geometric figures have the same size and shape. Okay. Now, by that description, we can make the jump that if it is the same size and shape, then they must have the same measures, okay? So a lot of times we got to make sure we keep those, equal measure and congruent as two separate categories. In previous lessons, if two angles are congruent, their measurements were equal, so we made that connection. And if two line segments are congruent, their measurements were equal, okay? So angles and line segments, we kind of already talked about those in the past. So here's what congruent polygon. This is a formal definition. Sorry, for some reason I can't talk right now. Two polygons are congruent if and only if their corresponding parts are congruent. Okay. So for instance, if these are the same, or if they're identical, okay, then that means their angle measurements must be the same and side measurements. That makes sense, right? Like, for instance, these two erasers right here, okay, are they the same? Yeah, okay. They have the same measurements, and their angles are the same, right? They're all, both of them are rectangles, and they both have 90-degree angles, so it works. That's what this is stating here, okay? If they're the same, then all their sides are the same, and all their angles are the same. A couple things. One, you see how, look at the angles for a second. Angle B and J, okay, they are congruent. And how we know that is by the number of congruency arcs. For instance, angle B has one arc, angle J has one arc. Okay, K and C have three arcs. Only those two angles are congruent to each other. And then H and A have two, so only those two angles are congruent to each other. Because here's the deal. In the past, we use these arcs as a means to say that, hey, these are the same measurement. But the reason why I don't use the same arc is because, well, we have other angles. So I have to differentiate between all three angles here, okay? I can do the same thing with the sides. AB and HJ are congruent because they have one congruency mark, one little tick mark. BC and JK have two, so therefore they're together. And then AC and HK have three because they're the only ones that are congruent to each other. Okay? So just want to make sure we understand that. Now what we can do is after we list everything that's congruent, we can come up with what's called a congruence statement. This statement is pretty powerful. This statement will tell you what angles and what sides are congruent. Okay, all compacted into one. When we create this statement, we have to be careful on the order. Okay, and more on that in the next slide. So in terms of what is a valid congruent statement, so let me go ahead and write down excuse me. Okay, and then this guy. Okay. Now, I have for us a picture, an example to go off of. We have these two triangles, and I marked everything that is congruent in both of them. This top part is a valid congruent statement for this, but this bottom part is not. Here's the reason why. The position of these letters will tell me what's congruent. Okay, what do I mean by that? Well, let's take a look here. This one is good. Okay, this is the good statement. Okay, why is it good? Take a look at B. B is in the first position. J is in the first position. Okay, so angle B and angle J, because they're in the first position, they must be congruent. Take a look at the picture. Angle B has one arc, okay? Angle J has one arc. All right, so this statement is matching the picture. I can continue. Angle C is in the middle position. Angle K is in the middle position. Okay, look at the picture. So here's C and here's K. They both have three arcs. Yep, they're congruent. And then A and H, two arcs, so it works. So the position of these guys is critical. Now, you're probably thinking, well, wait a minute, what about the sides? Yeah. BC, that side is in the first two positions of this statement. JK is in the first two positions. Do they work out? BC has two lines, right? Two arcs, or two congruency marks. JK has two. Yep, they're the same measurement. So that's good. How about BA? Let's go first and last position on both of them. So is side BA the same as side JH? BA has one mark, JH has one mark. Yep. And I can keep going. I can continue with this. So let's take a look at this guy. Why is this not a, see, I told you I can't talk today. Why is this invalid? Well, let's take a look. A and H. A has two arcs, H has two arcs. Okay, so far that's good. Okay, the middle letter is B, the middle letter is K. B has one arc, K has three arcs. There we go. Look at its position, not congruent. So yeah, this statement is not matching up with our picture. Okay? Does that make sense? So the order on how you write this statement is important. Now, an easy way to remember, like how do I write the statement? I go by the angles. See how angle B has one arc? Then A has two, C has three. So go in that order. This is triangle BAC. Okay? Then what I could do is follow the same order for this guy. I just realized I named it differently here, but you can name these infinite number of ways that you can name these guys. So let's look at this guy. So J has one arc, 2 for H, 3 for K, so JHK would be that guy. So here's another good one. So we'll put good here if you want to have another example. So triangle BAC would be congruent to triangle JHK. Okay, and to do that, I followed the arcs. That's how I named it. Okay? Questions? Not too bad. At first, it seems a little intimidating. It's like, oh, wait, there has to be an order. But if you follow the congruency marks, it's pretty basic. Okay, here's my first example. Show that these polygons are congruent by identifying all the sides and angles that are congruent. And then for the final part, we're going to write a congruence statement. Now, I literally just took a picture, okay? I took this guy and copied it over here. So yeah, they are identical. It's the same picture, okay? But it's just practicing how to write these things. So for angles, okay, what angles are congruent? Well, in this case, we're going to do it based on its position. A is to the left, right? It's located right here in the position. R is in the same spot as well, right? So on your notes, you can write angle A is congruent to angle R. Same positions, right? Okay, take a look at the next one. How about E? Angle E would be congruent to angle Q because they're both on the very top part. I don't need to have those congruency marks in there yet because, like I said, I just took this guy and copied it over. So there's no reason for me to include those right now. And I can continue, right? Angle D is congruent to angle S, and so forth. I'm just going to keep putting dots there. I think we could fill in the rest, right? Okay, sides. What sides are congruent? Well, it's going to be the same principle. Look at its position. So let's look at AE for a moment. Okay, side AE would be congruent to what? I think what? RQ would be the other guy. Then we can continue going. I'm going to keep going clockwise. We could say ED is congruent to QS. And I'm going to keep putting dots there. And we can continue going clockwise around the full picture. So we're going to keep writing all of these guys. All right? One small thing. Look at how I named these side planes. See how I went from A to E, R to Q. So I went from this position to the top, this position to the top. You want to maintain that, okay? you do not want to do this. AE is congruent to QR. You don't want to flip this guy, because see how you named the first one from A to E, from left to the top? This one you went from top to the left. The reason why you don't want to mix those is because when I write a statement, remember the statement tells me everything that's congruent, it's going to get a lot trickier to do that because you're flip-flopping your letters. It seems like a lot. It does. It seems like, why are we doing this? But the easiest way to get across to you guys is that math is a language, and how we write this language is critical. It's important. Just like in English, Spanish, Japanese, I mean, no matter what, German, French, list continues, but that's pretty much how we're treating it as. This is a language. We have to make sure we write it correctly. Okay, now let's write a statement to finish. Okay, so let's take a look. This is what? 1, 2, 3, 4, 5. They're both 5-sided figures, so we can call them pentagons, right? So we're going to call the first one pentagon. Now here's how I'm going to name it. You see how I started with A and worked my way around? I'm going to do the same thing here. So I'm going to call this one pentagon A, E, D, C, and B is congruent to pentagon. I'm going to do the same thing, same direction, right? R, Q, S, P, and T. So both of these, when I started naming them, I started in this position, worked my way clockwise, started in this position, worked my way clockwise. And we can tell if this works. Is A congruent to R? Yep. E and Q are in the second position. Are they congruent? Yes. What about the side lengths? AE, is that congruent to RQ? It is. First two positions, first two positions. Okay? See what would have happened if I would have flipped them? It wouldn't have matched here. Now you're probably saying, well, Mr. McCullough, it's the same thing. You just flip the order. I get that. But if you keep doing that for every single side here and you don't, and you're not conscious of the order that you're writing things down in, this is going to make even less sense, your congruent statement. The goal of this statement is, let's say you didn't have a picture. This is all they gave you. This is enough information for you to draw the picture accurately, or at least in terms of position where everything's at. So this is important. Okay. All right. So let's go ahead and take a look at this. You're going to complete the following congruent statements. And I encourage you to pause the video so you can do this. We can name these based on the picture or the statement. I prefer the statement because that's getting you practice in reading some geometry. And it's a lot more accurate than the picture at times. Okay, sometimes the picture, I mean, these are just triangles. There's only so many ways to turn or rotate a triangle. But if we're looking at, more complicated geometric figures, and more importantly, let's say we're looking at pictures with a mishmash of like triangles and quadrilaterals inscribed into a circle or something along those lines, then it can get a little bit trickier. AC is congruent to what? Well, AC has 3, right? DF has 3, so that must be it. But the way we name it is important. See how AC is in the first and last position? So it must be DF. So AC would be congruent to DF. You would write for that guy. Part B, BC. Now I'm not going to use the picture. I'm going to use the statement. BC is in the middle and last position. EF follows it. So this guy is congruent to EF. I don't want to put FE because, once again, it has to match how I wrote it in the statement. Okay, last one, BA. So that's the middle to the first. What matches it? ED, middle to the first. So BA is congruent to ED. Okay. Do one more. Example 3. Tell me what angles are congruent to these guys. And we can tell by the picture and statement. First one, angle A would be congruent to angle D. They both have one arc, and they're both in the first position. Angle E is congruent to what? Well, it'd be B. They both have 2 arcs, and if you notice, E and B are in the second position in the statement, so they match. Last one, angle C, they're both 3 arcs, and they're both in the last position. All right, go ahead and think about this one. The support beams on a fence form congruent triangles. ABC is congruent to DEF. We're looking at this guy and this guy. Which of these statements correctly identifies the corresponding angles or sides? So the answer would be D. Okay. Look how they named it. AC is in the first and last position. DF is in the first and last position. So that's correct. Okay. Look at choice A for a second. This is interesting. They said ABC is congruent to EFD. Look at how they named it. They went from A, B, and C. They went left to right. So if they named the angle over here, they should have went left to right, DEF, but they didn't. They went EFD. They went in a different order when naming the angle. So they named these angles wrong. These are incorrect the way they named them. And then this guy was named incorrectly as well. Okay? All right. Let's do some problem solving here. All right, let's have some fun. Oh, I went ahead of myself, sorry. The phrase if and only if in congruent polygon definition means that the conditional and converse are true. So what that means, if 2 triangles are the same, their parts are the same. Flip what I just said. If their parts are the same, they must be the same triangle. That's what that means. Now here's the other thing. If 2 polygons are congruent and their corresponding parts are congruent, saying that statement for every time you want to explain to someone why they're congruent can be a lot. So they abbreviate it CPCTC. All right. So this statement, corresponding parts of congruent triangles are congruent, we shortened it by using CPCTC. We took the first letter out of every word there. Okay. And once again, that just means if their parts are the same, they must be the same triangle. That's what that says. Okay? All right. For some reason, I must have had an animation there. But there you go. Okay. What I'd like to do is I'm going to do 2 examples with you. Okay? And that's it. The rest, my notes do have other examples if you want to try those out. I think these 2 would be fun. Okay. So I'm going to rewrite the statement. Triangle ITP is congruent to triangle NGO. And we want to figure out the measurements of X and Y. Okay? All right. Now, notice, this guy has an X and a Y combined. I don't want to go after this one first. Look at this guy here. It only has a Y involved. So that tells me a lot easier to go to. All right? Only have one variable to solve. So notice that represents angle O. So what angle is congruent to O? Look at the statement. O is in the last position. P is in the last position, right? So they must be the same measurement. So angle O is 6y minus 14. Angle P's measurement is 40 degrees. Okay? Now, some people might say, well, I can figure out what that is. All they did is they took this triangle and they rotated it. Okay, true. But what if they didn't? Right? Sometimes the picture can be misleading. It just depends on how your mind's working at the time. If you're a visual person, you can see the different rotations and transformations. If you're not a visual person, I'm like 50-50, okay, when it comes to those things. You can fall back to the statement. That'll help you out. Okay, now we just solve. Add 14 to both sides. 6y equals 54. Okay, divide both sides by 6. 6. Y has to be 9. Okay, and we can see if it works. Both of these are 40 degrees, right? So let's plug it in. 6 times 9, that's 54. Minus 14 is 40. Yeah, it works. They're both 40 degrees. Okay, we're not done yet. We have ng to solve for, right? Take a look. Ng has the x value. Now, since I know what y is, I can plug that in. So ng, what's that congruent to? Well, if you can see by the picture, that's great. If not, ng is in the first two positions. It is in the first two positions. So they must be congruent to each other. So that means x minus 2y equals it is what, 7.5? Something like that. Okay, so we have x minus, we know what y is now, right? 9. So what's 2 times 9? We'll make it 18, right? Equals 7.5. Add 18 to both sides to finish. So x is 25.5. My final answer. Okay. Usually this is time I ask for input, questions, but oh, this is so weird teaching through a video. I miss the interaction. I like to have some input as we're going through this. Okay? All right. Let's talk about the last one here. And the reason why I want to make this the last one is I don't want to make this video too long. Okay? Like I said, I'll have my notes uploaded for you. So we have here triangle FHJ is congruent to triangle HF and G. And we want to figure out what the value of x and y are. Okay, we can do that. It's not too bad. So let's take a look at F. See how angle F over here has an x value to it, right? Okay, and in fact, we should be a little bit more specific. We could call that, and I'm in the wrong position here, it's this triangle. I could call that what? GFH? Why not? Let's call that GFH. Remember, the middle letter is what you're looking at. So GFH. That, see how I went from GFH, I went in that direction? That must be congruent to angle JHF. And if you look at the picture, JHF, that's this guy here. So 6x plus 8 equals 35. A lot of times people look at this and say, well, they're the only two angles that are marked there, so they have to be congruent to each other. I get that, but it's good work when it comes to reading the statement. Subtract a from both sides. Okay. So it's going to be 6x would equal 27. Okay, divide both sides by 6. And we should get 4.5 for that guy. Okay, now let's look at the next one. Y is with this side, FJ. Okay, so FJ is in the first and last position. It must be HG, would be congruent to first and last position, which would be this 2.5 over here. So 2y minus 3 equals 2.5. That's what we have for an equation. Add 3 to both sides. 2y equals 5.5. And for my last step, divide both sides by 2. Almost out of space. This would be 2.75 as your answer. So let's see. That's going to be choice A, right? That's our answer. 4.5, 2.7. So that's it, guys. We spent the first part of this lesson video talking about congruent statements and how to read it. The second part of the video, we used a congruent statement to solve for some measurements here. All right? So, like I said, rest. Feel free to look at my notes to see some other examples if you need them. Other than that, guys, that's it. Hope you're doing well. Hope you guys are enjoying your day. And until next time, I will see you in the next lesson.